Let's derive the range equation. Recognize that there's a very big restriction on this, that if I'm shooting up at some angle theta, the big restriction is, well, no air resistance, as typical. That's not the big one. But the big restriction between this and, let's just say, a projectile motion lab is that the final height and the initial height must be the same. So final height equals initial height. So let's go ahead and we have, well, basically a few characteristics here. We have displacement, we have initial velocity, final velocity, acceleration, and time. This will be my horizontal values, and this will be my vertical values. I know that horizontally, that there's some range here, r. Vertically, 0 meters. And we'll set up a coordinate system here. So I hat to the right, j hat up. Initial velocity, well, it's set at some speed v at some angle theta. In other words, a velocity at v theta. So this will be v sine theta, and this is v cosine theta. The final, well, acceleration is negative g. G being the acceleration due to gravity, and negative because the acceleration is always towards the ground when you're dealing with no air resistance and things moving through the air with no other forces acting on it other than the force due to gravity. I know that the acceleration in the horizontal direction is 0. This is, again, from the moment it is launched, in meters per second squared. Now, final velocity, I know it's going to be going up and straight down. We can derive this. This is going to be negative v sine theta, and this one will be v cosine theta. Just from experience, I know that because of symmetry, the speed has to be the same when it's at the same level, given, again, well, given that the speed will be the same at the same level. The only force acting on it is the force due to gravity, sort of flash forward. It's known as a conservative force, so energy is conserved. So, and the horizontal speed will be the same because acceleration is 0, and so therefore the vertical speed needs to be the same as well. But what I want to do is find r. So first thing, we need to figure out what is the time in the air. And exploiting this right here, we have negative v sine of, well, let's start out with the formula. We have Vf equals Vi plus At. So V sine theta, negative V sine theta equals V sine theta minus Gt. So negative 2V sine theta equals negative Gt. And the time becomes 2V sine theta over G. So now we know the time for both of them, because again, horizontal and vertical time are the same. R, well, I know that delta S is equal to Vi plus Vf over 2 times time. And since Vi and Vf are the same thing, horizontally speaking, then this just becomes V cosine theta t, or the classic middle school formula of distance equals rate times time. It is in only one direction, so you can get away with it. Horizontally, only in one direction. And so we know the value for time, and so r, which is the displacement, is equal to V cosine theta times 2V sine theta over G times t, which becomes V squared 2 sine theta cosine theta over G times t. And 2 sine theta cosine theta is just sine of 2 theta, V squared over G. Oops, that t does not go there. So substituting the value found for t is this right here. And then rearranging it, we get the V squared up front, the 2 sine theta cosine theta, and then divided by G, and then 2 sine theta cosine theta is just a trig identity. That's the sine of 2 theta. And so we have that. Now we can find the angle which will produce the maximum distance. So in other words, I want to find the maximum of this value for r here. So with respect to the angle, so dr d theta, I'm going to set that equal to 0. Since the initial speed is some constant, I mean, it's not like speed, the initial speed can vary because it happens at a single moment. And so that becomes v squared, and then the derivative of this, derivative of sine is cosine, so this is the cosine of 2 theta times, using the chain rule, times the derivative of 2 theta divided by g, which is just some constant. So, and set that equal to 0. So those are all constants there. Those are all going to just disappear. So we want to figure out, when is the cosine of 2 theta equal to 0? Well, 2 theta, when 2 theta is equal to 90 degrees, or theta is equal to 45 degrees. So at a 45 degree angle, we get the maximum range. This is a maximum. Now, recognize if it's at a different height, then this is not the correct angle.